Hello guys, you're welcome once again to Mostly Academy Physics channel. It's been a long time out here and I'm very happy today to come out here on this particular channel to make another video on the physics channel. Like you all know, I announced the other time that the channel is under suspension with our problem with Gmail accounts, but to the glory of God, we are able to restore it back, and I'm glad to be here once again to continue with my series of high school physics as well as college physics, and the aim is to complete all the syllabus of physics chapters from what A to Z. Now, to the glory of God, we are going to do a kind of a welcome back video today, and on today we are facing or looking into the minimum deviation of light using the prism. So we are going to do the proof as well as solve just single example. So I'll do the proving. It is not important for some set of students, but the formula is very important because some questions are directly formula based questions. So guys, if you are new on this particular channel, you can consider subscribing to this channel as well as like and drop your comment box on to know how to serve you guys better. So I will start with the topic of minimum deviation using a triangular prism. Now, to start with, my dear students, to understand the concept of minimum deviation, you might have studied about the movement of light. Apologies, I just want to prove a formula and use it to solve questions. Doing so, I'm going to bring out a triangular prism, or basically say a triangle, and from the triangle, I'm going to be able to show you what I want to show you better. So let's do something, guys. Now we have it. I'm here with you guys. I'm not going anywhere. So this is a triangle, which I believe you guys can see. I hope you can see it. So, and in this triangle, if it is not too small, and if it is too small, I can still increase the size. So I think it's not too small, I admit. I hope you can see it. But I'm going to need a bigger one. So let me go with a bigger triangle for understanding's sake. So let's make it a little bit enlarged. So that we can actually have what we have, so that we can understand the concept very well. I'm not going to waste time. So this is a triangular prism. So now for here, we are going to incident a ray of light into the prism, which you might have studied from angle of incidence. When the ray of light is incident, it can be what? It's going to be what? Refracted. The change in direction of light is called refraction. Apologies guys, I'm trying to bring out what I'm going to use to draw out the reflected ray, the incident and the reflected ray for understanding sake. I think I have one. So this is a triangular prism, guys. I hope you are still with me here. I'm here with you, I'm going nowhere. So this is a triangular prism. We have learned from junior classes that the ray of light is incident. Now, on this prism, as it is incident, that diagram is not drawn to scale, it is coming from air to glass. From the knowledge of refraction, the change in direction of light as it passes from one medium to another. I am not taking concept of refraction. I am only focusing my concept with respect to this minimum deviation of light, and I will explain a little bit of what details. Now, incident ray of light was incident from here to glass. As it comes here, we see it will be refracted inside the prism. Refraction will come like this. It will be not straight, so you have to bend it a little bit. Now it is now coming from glass to air. That's from a rarer medium, which we call a less dense medium, to a denser medium. So it will bend away from normal. So when it comes out, so as it comes out, it will now bend away from normal. So that's the first thing you need to do. Then having done that, the next thing is just to show your normal ray, incident and refraction. So if we do that, like I said, my diagram is not drawn to scale. It's only for the sake of understanding. So that is the first incident normal, and this is the second. Just want each of them to make sense. I'm supposed to make this one also the same line with that, so that we can have a kind of good illustration. I hope students understand what I'm trying to do. So here we can now put our incident normal ray for understanding. So angle between the incident ray and the normal ray is called the what? Angle of incident. It was incident here. Inside here, it's what? It got refracted. I'll call it R1. So here it's emerged to the air. We call it angle of emergence. And at that point, when it emerged, this line I drew here is not a good line, because the line should be better than that. So because of that, I want to clean out this line and draw the normal ray in a better way. So doing so, I'm going to do, it should lie between these and this. And it's because I'm trying to make them join, which I'll do later as we proceed. So now I'm saying the second one is coming and it's emerging to the air, and the ray of light is incident inside the glass. So I'll call it what? Is refracted inside the glass. Now, here is called the base of a prism or the base of a triangle. You guys know that. Here is called the refractive angle, we call A. So it is called refractive angle. Please note that it is called refractive angle or the angle of the prism. Anyhow you call it in your junior classes is actually acceptable. So here, the only thing I want you to know is that from experiment, for a ray of light, listen, because these are things we do in experiment. For experiments, for a ray of light to be minimally deviated, the ray of light must be symmetrical. That's just, let me write symmetrical ray of light. Symmetrical ray of light calls for minimal deviation. I hope you guys are following. So what I'm trying to say is that for a ray of light to be minimally deviated in the prism, you have to have some certain condition. The one you guys have studied in your junior class, which I think you all still remember very well, is the one that states that the emergent ray must be equals to, when I say symmetrical, that means equality, must be equals to what? The incident ray. That is, the angle at which this thing is coming out must be equal to the angle at which it is being incident. That's the first condition. Another condition is what? The refraction inside the prism must also be equal to what? Each other. This R1 also must be equal to R2. So if we have actually say we want to have minimum deviation, that means we are plotting a graph of incident ray against what? Against what? A deviation against what? Incident ray. And if we do that experimentally, I'm not going into that. I can show you in terms of some graphical question. You are going to have something like this. If I is a function, if this is a function of I, I'm going to have something like this, which is like what? A graph of minimum deviation. So the point of minimum is this point in any graph. You guys know this is minimum deviation, whereby the point of maximum are what? Are 2. You can see. So always keep that in mind. This is a minimum deviation we call GM. But that is not even where we are going, to be honest. We are actually going to derive the formula, which we call the formula for minimum deviation of light. But we have actually noticed the two conditions. Ray of light must be symmetrical. And when they are symmetrical, emergent ray must be equal to what? Incident ray. And as well as what? The refraction angle of the first one must be equal to the refraction angle of the second one. Now to the derivation. To derive this, you might have also studied in your junior classes what we call the Snell's law. I'm going to apply the Snell's law to explain the concept very well. Now, Snell's law says n is equals to, n is refractive index, which is as the ray of light is moving from here has constant refractive index of 1. It moves to the glass has a particular refraction we call n. But basically everybody should know n equals to sine I over sine I. So during that, guys, excuse me, during that, guys, I'm going to use some kind of my triangle property and some kind of my what? Quadrilateral property. So let me be quick to explain that for us to understand. Now, we try to elongate this line. That's what I'm trying to do the other time. In such a way that, sorry, guys, diagram not going to say, they are going to form a triangle, you know. It should be something meeting around here. But I am not drawing a diagram to split for you to see. Now, from here, if you watch here, if we call this thing triangle A, B, and and C. And I call this point triangle D, E, and F. My admin asked me to change marker to black. Thank you for your information. So now D, E, and F. You can see that what, because it is symmetric, we can say this angle and this angle. I'm taking this as also a triangle. I told you the diagram is not drawn to scale. So now, from angles in a triangle, you can see this is no more a triangle. A, E, F, D. A, E, F, D is like a what? A cyclic quadrilateral. And from the knowledge of cyclic quadrilateral, the opposite angle of a cyclic quadrilateral is always equals to 180. I hope you can see this. So what I'm saying, the angle here, the angle, refractive angle or the angle of prism is equals to what? Is opposite to the angle here. And the two angles here must add up together to be equals to 180. That is quadrilateral law. So if this is 180, this guy will be 180 minus A. I hope I'm communicating. And that one will now lead me to what? To the first derivation of the angle of the formula, which is very, very important. Now, in triangle D, I hope I'm perfect, D, E, and F, we have sum of angle in the triangle. Everybody knows. So we can now say from DEF, the proof is starting now. So we say from DEF, we can say angles in triangle, we add them together, R1 plus R2 plus 180 minus A is equals to, what's the sum of angle in triangle? 180 degrees. So it's equals to 180. That's the first thing. Recall, for minimum deviation to occur, R1 must be equals to R2, so the R's are equal. So we can just say R plus 180 minus A is equals to 180. What happened? 180 gets cancelled out. We can now move this negative A to the other side. Say A is equals to R plus R is 2R. This formula is the first derivation or the first formula I'm going to plot to ring for you guys to understand. That means we are saying the angle of prism, refractive angle, is equals to 2 times the angle of refraction. Most of the question in your post UTME, WAEC will test you on this simple formula. I hope students are following. So that is the first formula we are deriving. And the next formula will now be the formula that will explain the concept of minimal deviation itself. What do we call minimum deviation in a word? Triangular glass prism. Now, what we call the minimum deviation of a triangular prism is just the angle that is formed. Then I'm speaking grammar now, the English form of it, the language form. The angle that is formed when the incident ray, this is the incident ray, brought forward, and the emergent ray, you can see, brought backward. I hope students can see that. The angle formed when the incident ray is brought forward and the emergent ray is brought backward. Most of the time you see this in your textbooks, you don't understand how they come about it. And that's why I just want to explain for some questions that ask you to derive, especially for DUPEP students and IGME students. Now, what you need to put in mind here is just angle formed between the incident ray brought forward. That means you are tracing the incident ray to the top and you are taking what? The emergent ray what? Backward. So that is what we call the deviation angle, and that angle here is called minimum deviation. I'll call it DM because I use DM here, not direct message, and you guys are used to saying under what? Your chat box. Now DM here, I'm taking DM as what? Minimum deviation. Now if you watch and we make an angle, or let's say basically, and me always tell me to change color. So let's say you can see this is also forming something like a triangle. So we've used A, B, C, D, E, F. What? Let's say X, you can see X, then Y and Z, not E and F. But this is only for somebody that can see very well. Because if you can't see very well, you won't be able to know that the total angle at this point is I. Watch very well, please. The total angle at this is I. The angle here is R1. So the total angle from here to here is I. The total angle from here to here also must be I. The same thing here. You know, we say if a ray of light will be minimally deviated, what happens to the emergent ray? The emergent ray must be equal to the angle of incident. That means E is also equals to Y. in this form too, you can say the total angle here is also what? I, which is E, for minimum deviation from the condition we had have here. So if the angle here is I, and we are told that the angle at this point here is what? Is R. I mean the total angle here is also what? Is also I. You know what I mean by I? At least we call it what? Vertically opposite angle are equal. I'm not teaching mathematics, but physics is math. You have to know that. Now, having said that, the next thing you have to keep in mind here is just don't get tired, please. It's important to watch this video to the end. Now, what you need to know is that the remaining angle here, which is what you need in this triangle, is EF. Because you want to use the property of triangle that says a stereo angle of a triangle is equals to sum of two opposite interior. This angle here and this angle here. So if everything is I and then this place is R, this will be I minus R. This will also be what? I minus R. It's just that the total angle from here to here is 20. Here to here is now 10. The remaining one would be what? 20 minus 10. So that is what we did there. So now we can now say, oh fine, that short triangle which has S, E and F is now having an stereo angle. From mathematics, a stereo angle is equals to sum of two opposite interior angles. So that is what I'm going to do now. So let's do that together to get the second formula for our minimum deviation. So what's the stereo angle, my dear student? It is what? DM. The minimum deviation angle is now equals to a stereo angle is equals to sum of two opposite interior angles. So what are the two opposite interior angles? The first one is what? I minus R plus, you have to put a bracket. I hope I'm not cutting. I minus R. What do I know? When I expand this bracket, I'm going to have I minus R. I'm taking it step by step. Plus I plus times minus R. I hope students can see that. What is I plus I? 2I. I mean, I'm up there. Hope this is not cutting. So what is minus R minus R? Minus 2I. So that means minimum deviation is also equals to this, which I can factorize because 2 is common. I hope you can follow. You guys are getting it. I can say therefore from here, permit me to write here that dm, hope is still writing, dm is equals to 2 open bracket I minus I minus R. Another person can know this formula. So both of them are the same thing, and it's also very important for you to know if you are given incident angle, incident ray, and what? Refracted ray directly. You can say dm is equals to open bracket. What I did is just a stereo angle of a triangle is equals to. So this is the second formula I'm deriving. This is the first formula I'm deriving. So be careful about directly. Some question we ask you to find the value of what? Minimum deviation angle. Angle is measured in degree. Place is always equals to what? 2 open bracket what? Incident angle minus refraction angle. So the overall formula which I want to derive now, which is common in your high school, is the one that involves the what? The concept of your refractive index with respect to what? The formula we have got in there. So it all depends on anyhow you want to do it. Just let's focus on how to what? Get the formula. But here I'm going to do something that is like a little bit of what? Mathematics. And you guys know when I say a little bit of mathematics, if somebody asks you to make I subject of formula in this formula, I hope you guys know how to do that. It's very, very simple. Because what you do is just move that one to the other side, then divide both sides by 2. I hope I'm communicating. These are simple things you have to understand. So look at another way in which I can write this formula. For somebody that knows mathematics, I will continue from this side. Watch. Here I can say, yes, then I say dm is equals to, because some of us are just lazy. It's not that we don't know what this is. 2I, I mean I'm not cutting, 2I minus 2I. What is 2I? A. So if I say 2I minus A, that's the same thing. So I can say here, dm plus, when this one move from here, A is equals to 2I. Let's make use of formula. I will now be equals to dm plus A over 2. So it's also important in some question when you are giving minimum derivation directly, you can also apply this to get your answer. When minimum derivation angle is given and the triangular prism angle of the prism is given, you can directly get the value of what? The value of incident angle. I hope I'm completing. So lastly, from our next rule, I'm going to do that just before I move to the next slide to do your example. I have a few minutes more, and doing that, I think I'm going to create my triangle for you guys to be able to see what I want to do. So doing that now, guys, I'm going to do a kind of rough work for ease of access. So let's see what we have. Final formula which we are going to use to solve our example. Many of you will say, why am I going through this stress? It's because some of our examiner do ask students to prove this particular formula. And that is why I'm going through this stress. I don't want. So everybody knows from junior classes that refractive index you call N. Basically, in most of my own video, I use mu. It is the same thing. It's the same. It's always written as sine of angle of incidence over sine of angle of refraction. Everybody should know this. And if you don't know it, there is always a first time to everything. I want to use 25 minutes. I hope I'm still very much on time. Not on time. It's more than 30 minutes I've used. So I have to just move. Now, because I have an example, so 30 minutes is maximum I have for this video. So let's now substitute because we are going somewhere. Equals to sine, my dear student, what is I? I equals to what? dm plus a over 2 all over sine. What is R? Please make us a formula here. R equals what? A over 2. So this is the formula we are coming to meet this morning, and this particular formula is applicable to solve most of your direct question for your what? Most of the exam-based question when you have what? N equals to sine dm plus a over 2 all over sine a over 2. Most of your textbook can write it in the simplest form, and writing it in this form like saying, I hope I'm still there.
Yes, sir.
Yeah, thank you very much. So I can say this formula can also be improvised and rewrite or generalize, anyhow you want to say it. N equals to sine, instead of writing, instead of saying 1 over 2, sine half dm plus a all over sine half 1 over 2 is what? The same thing as a over 2. And this is what we want to derive. And luckily, we were able to derive it. And this is exactly the formula you have to keep in mind for any level, either O level or A level student. But all this generalization of formula are important for quick solution. But for this class, I'm only going to do one question, which was extracted from UTME question. So let's see that. Admit, please, the next question using the formula we have there. Thank you very much. Now, in this question, we are asked to calculate the angle of minimum deviation of a ray which is refracted through an equiangular prism. Now, that's a little bit of math. Equiangular prism. What is the sum of angle in triangle? 180. So if it's an equiangular, that means the angles are equal. What will be the angle if angles are equal? How many sides are in triangle? 3. So each of them will be 60, 60, 60. That means if I'm drawing my triangle, permit me to not to draw triangle, but to show you something. So if you see this in an examination, you don't need to waste your time, because what you just need to do is just to understand the concept. Once somebody understands concept, like I do say, you don't have any problem. So it's just like saying you have something like this. And if you have something like this, what will be the angle there is just the simple angle we've been talking about. So this guy will be 60. That means your angle of prism A is equals to 60, because everything is 60. It is an equiangular prism. Very important. So with refractive index 1.4, that means our refractive index N is 1.4. We are looking for the value of angle of minimum derivation. GM is what? Question mark. How students are forming this? So by and large, what we just need to do here is just to apply our formula directly without any time wasting. So we say, from the formula we just derived, say refractive index N equals to sine 1 over 2 dm plus A all over sine 1 over 2A. So let's substitute the values and get the answer. Now doing so directly, we can say N is 1.4 is equals to, sine 1 over 2. We are looking for dm. We know A is 60. Let's make it fast. Over 1 over 2 times 60. 1 over 2 times 60 over 2 is what? Sine 30 degree. Everybody knows sine 30 to be half. I hope students still remember that sine 30 is right. So if you multiply 1.4 times sine 30, calculate what? That is 0.7, because it is half of what? 1 over 2 times half of 1.4, which is 0.7, is equals to, I can just say this is sine dm, please listen, plus 60 over 2. So this is where something is. This is where most students do make mistake. Because most students want to say, this is over 2, they have to cross multiply. This is where the issue comes. You cannot cross multiply now. And that is why you can say, and this thing is, that's why when I was writing this stuff, I always try as much as possible to make sure that what you understand that it is 1 over 2. So if you are writing in this format, you need to be careful. But if you are writing it in the format of 1 by 2, you also need to be very, very careful. So that is why I always urge students, in order not to make mistake, to write it in the format of 1 by 2 dm plus 60. So before you can do anything here, to remove sine, you are going to take sine inverse of both sides, mathematics way. So let's take sine inverse of both sides. So sine inverse of 0.7, I don't know. So I mean, minimize and give me calculator. I'll just minimize from the place. Quickly, let's see, because I need a scientific calculator for understand. Thank you very much. So here, let's take arc sine of 0.7. This is a calculator. I hope it is visible right there. Thank you very much. This is CE. Then we have, how do I go for sine? I think it should be on trigonometry. So second function, arc sine of, it should be 0.7 first, 0.7. Then I have a trig, second function, arc sine. So 44.427. So I'll go with that. 44.4, full screen please. 44.427. Thank you very much. So we have that is 40 arc sine of this. I'm taking sine inverse of both sides. Please note that. Then sine inverse of sine, we cancel sine. Please note that. So sine inverse of both is 44.427. Thank you very much. Equals to sine inverse, we cancel sine. It equals to 1 over 2 dm. But now you can now say dm plus 60 over 2. So what do? We cross multiply and we finish this question. So finishing on the finishing note, we have this times this should be 88.8, I hope I'm not cutting, 88.84 or 88.84. I'm removing this. That's for me to be able to do it with that calculator. Is equals to dm plus 60. Let's do this one. 88.84 is equal minus 60 is equals to dm. I don't want to rush you. So we can say dm here is equals to 28.84. So dm is approximately 29 degrees. So please, this is the way you are expected to solve this type of question. What you can see is a formula-based question, and directly you can apply formula. Some other question in your post-studium will not be a comprehensive full formula-based question like this. So you just be on those short formula I've actually written in the first place. So guys, this is where I'm going to solve. Choice A is the correct answer to this question. I'll see you guys soon in my future video. And if you are new to this channel and you love what you see or what you've seen, you can consider subscribing to the channel. And by the grace of God, I'll continue posting the full concept video, shorty, the way I call it, in this manner. So at least you're going to be seeing 2 videos per week by the special grace of God. So see you guys soon. Bye for now. Thank you.